All right, well, my clock is showing 11, so I think we can get started. So thank you, everybody, for joining us today for this webinar on Introduction to Softree Optimal. My name is Kamala Thorpe, and Jack Rymack will be here with me doing the demo today. So just before we get started, a little bit about us. We're based in Vancouver, BC, and we've been developing corridor design software for the last 25 years. And at the core of our company, we have a very user-centric philosophy. So we focus on engineering over drafting, and more importantly, we make our software simple and easy to use. We really try to stay far away from the steep learning curves that exist in the design software industry. And we're always trying to tackle new problems, so streamlining LiDAR LiDAR capabilities is one of the problems we've been focusing on recently, and also this optimization technology that you'll be seeing today. So just a quick outline of what we're going to be covering today. I will be briefly telling you a little bit about what Softree Optimal is, and then Jack will go on to the demo part of this webinar. So he will do an initial alignment setup and show you how the costing functions work in Softree Optimal, and then he'll also do an optimization. And then at the end, he will show you how to compare design options using Softree Optimal. At any point, you can ask questions using the question panel. We'll try to keep our eyes on it and answer them as we get them. And also, we're going to be recording today's webinar, and we'll send you all a link sometime later this week or next week, and you can pass it on to anyone who missed the webinar or if you would like to watch it again. So just a little bit about what Softree Optimal is. We have a little diagram here explaining what it does. So Softree Optimal is a vertical alignment optimization tool. So it uses a mathematical process to determine the lowest cost vertical alignment based on the horizontal alignment and whatever constraints and standards are entered by the user. So you have your existing ground, horizontal alignment, cross sections, and other constraints and costs, which Jack will be going into a little bit more detail about. And Softree Optimal is, we've been developing this technology for a number of years now in conjunction with the math department at the University of British Columbia here in Vancouver. So benefits of Softree Optimal. The main benefits of Softree Optimal is it saves engineering time and construction costs. It saves engineering time because it automates part of the design process, and it saves construction costs by mathematically minimizing earthwork. So the optimizer typically can reduce construction costs by 10 to 30%, and sometimes even more depending on the project. And Softree Optimal is also a dynamic design tool, so it provides you with real-time costing information as you design. This allows you to generate multiple optimal alignments quickly, which allows you to quickly compare and quantitatively compare different design options, whether it's design speed or different horizontal alignments. Jack will go into more of that in the demo today. And Softree Optimal is also compatible with other design software packages. Today's presentation will be done in RoadEng, but Softree Optimal can also optimize designs done in Civil 3D, so just keep that in mind. And before I pass on to Jack, these are our next three upcoming webinars. We'd love you to join us for any or all of those. And with that, I will pass over to Jack, and he will show you Softree Optimal in action.
Thanks, Cam. Hello, folks. My name is Jack Rymack. I'm going to be demonstrating the Softree Optimal software for you today. I'm going to start by opening up a design that's already been done, a manual design that's already been done by a designer. I'm going to show you, first of all, talk a little bit about costing. Let me just change something here. I want to go back to my mass hall diagram. I'll change this back later on. Okay, so you can see that we have a little bit of cut, a little bit of fill, and some borrow and some waste. from this manual design that was done by somebody. Costing, first of all, talk a little bit about costing. This design done manually is going to cost totally around a little bit over $1 million. The cut costs are $736,000 some change dollars, and the fill costs are $187,000, and then we got haul costs and loading costs. Where do these costs come from? Let me just go into our table here, our ground type table. So every material has a associated cost. We're using a common material here. The cost for this common material, if we click on the cost tab, is $12 for cut, $4 for fill, and then we got some hauling costs, free haul, overhaul, and end haul. And we have some loading costs, basically just for overhaul and end haul. Let's see what happens if I decide to change my excavation cost to $20. See, this number is a little bit over 1 million. This should drastically change once I change that cost. There. Oh, wait a moment. It hasn't changed because I have to recalculate my costs. I'm going to turn on to automatic. There, so it's gone up from just over 1 million to 1.5 million. That's quite a significant change. Let me change back my costs to back to what they were before. $12. A little bit more about costs. Solid rock, for instance, has $48 for cut, $4 for fill. Gravel has the same as fractured rock, is $24 for cut, $4 for fill, and the same hauling and loading costs as all the other materials. Let's go on to optimization. So once I've got a cost for a manual design, I might want to optimize it. Let me just try that for you. I'm going to go into press the new button. Just call it test. Go to my standards. I'm going to start by the one that's the fastest. Obviously, you want to start with the easiest and the fastest one. That's the curves fast. Instead of starting with slow, just get some options. These are back-to-back curves usually. And my design speed for this design is around 80 kilometers per hour, which is going to be a K value of around 40, 45 or so. Control points I'm going to add at the start of the alignment. I want to tie that down to a the elevation that's at the start of the alignment. I can also tie the end of the alignment down, and also any other control points you might have along the road, such as bridge abutments. Let's say you want to also have a certain elevation above a culvert. You can also tie that station down to a specific elevation. I'm not going to add any more constraints, but just keep in mind the more constraints that you add, the longer it will take to find an optimal solution. I'm not going to talk about pits yet. I'll talk about that later on, and I'll add some constraints later on as we proceed through this. I'm just going to add one constraint for now. Control points, and then process. One thing I'd like to do before I actually do the optimization, I'm going to see if it's actually feasible. You can click on the full feasibility, and it will tell me if this all those constraints and standards that I put in to that panel will actually work. Yes, it is feasible. It's telling me that based on my current constraints and standards, that this optimization is going to be feasible. Let me just go on to the full optimal profile. That's fast. Done. So we did find a solution, which is good. And the optimal solution is going to cost $698,000. Total cost $502,000 for the cut costs, $167,000 for the bill cost, and $28,000 for the hauling costs. So we've shaved off quite a bit of off our manual design. So our manual design, if you remember, was just over $1 million. Shaved off quite a bit of cost off the alignment. And there's that new alignment right there, that blue line. You could set that as current. I'm going to show you how to change my options, try different, all my curves are back-to-back curves for this, so I'm just going to change it so it doesn't, so it's, excuse me, not back-to-back curves. Change it to a curves and tangents option, and I want a 50 meter distance between my my curves and my tangents. Proceed, process. Found a solution. This number right there, if you saw it really quickly, it was at 7.81 point. What that means is it's the optimality gap. We are at most that percentage away from optimal, and it found an optimal solution quite quickly, so we didn't have to wait for a long time. Sometimes you might have to wait for quite a bit. There's my next solution. It costs a little bit more. You can see we were under $700,000. When you constrain your optimal design a little bit, when you give your design a little bit more constraints, you will get higher cost roads. Let me add one more constraint, and then I'll show you my Optigraph graph. I'm going to change my standards back to fast. Turn that off. And then add one more constraint. I'm just going to add one constraint here. I'm not going to, there is a whole bunch of constraints you can add. You can add right-of-way constraints. You can add minimum cut, full bench cut, minimum fill, whether it's going to have side cast or not, and this is the one that I'm going to add. I'm going to add a direction of earth movement. I'm going to add earth movement only in the backward direction, meaning towards lower stations, and then just see what it gives me. Proceed. Found a solution. There it is. It's going to cost a little bit more because we constrained it a little bit more. It's going to cost more than the solution that we had before, which was less than $700,000. It's going to cost $735,000. Let me just show you my Optigraph graph and show you that the Earth is actually moving in the downhill direction, which is good. Yes, all of the overhaul and end haul is moving down in the downhill direction. We do have a little bit of the free haul and overhaul up here at the top of the hill moving in both directions, but that's fine as long as we got our downhill Earth movement moving mostly in the downhill direction towards lower stationing. I'm going to change that back so that I don't have any constraints. Go back to my previous tangent, 50-meter tangents and 50-meter curves, and then re-optimize. Just want to see it's taking a little bit longer, so I want to see if it's if I've actually left something on that I shouldn't have. Let me just go back to fast curves. That's a good question. Somebody asked after I've done my optimal trials, how can I delete the unnecessary profiles? I'll show you that in a sec. Just bear with me for a sec. I'll show you how to do that right now. All you do is just click on the profile that you don't want and you press delete. Let me just start a new optimization. So you can change your, if you want to up this to a 100-kilometer-per-hour road, or maybe even less than 80 kilometers, you can change this K value. I'm just going to leave it as it is. There, it's done. Let me quickly show you how to change the horizontal, and then we rerun the, so we do not have a horizontal optimizer yet. What you have to do is, if you want to try different horizontal solutions, all you do is you manually change the horizontal alignment and then go back and rerun your vertical. Process again. So our vertical previously was around 700 and I think it was around 704. That upped a little bit more because I moved my horizontal. but we should have a different solution. We'll see if it's less expensive or more expensive once this finishes processing. Done. It's going to be less expensive. It's going to be around $697,000. So just by changing the horizontal alignment and rerunning the vertical, I shaved a little bit more off of my cost. All right, there is one thing that I haven't talked about. This specific design is not asking me to do this, but it might ask me to get to the optimal solution. The optimizer might request that I put in either waste or borrow pits. I don't need to do that for this design. So I'm going to open up I'm going to show you a different design and just quickly show you what you get if you run try to do an optimization and don't add your pits beforehand. You just need a few more minutes of your time. I am going to try to keep this demonstration to under about another 10 more minutes or so. I've got a lot of sections, so I'm going to just turn those all off and just put in 20-meter sections. Standards. I want to do fast, and I'm gonna. This is a low volume road, so I'm just going to put in a K value of 5. I'm going to add control points at the start, and just keep my costs, my default costs. I'm not going to add pits yet, but I'll show you later on how to add pits. Borrow and waste pits, or actually just waste pits for this one. Make sure that I press add edit for all these because I will get some strange results. I'm not going to do a feasibility, I'm just going to do the optimization. It's giving me a cost. There's that optimality gap that I talked about. Let me just talk a little bit about the optimality gap first before I talk about the cost. 16.12% is the percentage that at most we are away from optimal. Here's the cost of this road. It would cost around $455,000 based on optimal solution, but we are unbalanced at this point, so that's what UNB stands for. Why are we unbalanced? Let me just see what it's telling me. It's telling me that we have a huge overhaul and we need to put in a waste pit. Yes, it will overwrite the existing one. The question was, if I accidentally run the optimal without creating a new profile, it will overwrite the existing one without warning undo any suggestions. Well, the good thing about that is that the optimizer is quite fast, so you could rerun that first optimization and then run a second one and so on and so forth. You can't go, unfortunately, you can't go back and unless you save the one that the design that you actually had with the first test. You're going to have to rerun all of your scenarios over again. Does that answer your question?
You can have multiple vertical alignments at the same time.
Yes.
That are shown, so you could also create create a new one, right?
Yes, but she said if she accidentally overwrites her
oh, I see.
new one, how does she go back? Or he, I don't know if that's a he or she. You would have to go back and rerun your first scenario and then start a new one again. Okay, so the reason that I'm having that problem that I had before is because I've got a huge overhaul and I've got to add a waste pit. The software is telling me that I should add a waste pit. I'm going to do that. Go to my options, pits, and I'm going to add the waste pit at around station 3500 or so. Process, proceed. So now it's giving me a slightly higher cost, but it's done. Basically, I don't have to wait forever and a day to it. The best alignment was found. That's good news. Let me just show you where that waste pit is. I'm going to go into my Optigraph. The waste pit is it's pushing all the material down this way. I could have it move part of the material down to this side and then back down that side and put the waste pit right there if I want to. So all the material is moving down to that station. There's another question. Yes, we could. The question was, in your software update, can you consider including a warning message before overwriting the profiles? I will pass that on to the people that deal with that, but I think we should be able to put in a warning message. So basically, that's all I wanted to show you. Thank you very much for attending our bi-weekly webinar. We are a little bit out of step because we this optimal introduction to Softree Optimal was supposed to be done a couple of weeks ago. So that's why we have 2 web demos this week, one today and one tomorrow. So please sign up for as many other future web demos as you wish to. We have different topics every couple of weeks. We try to repeat our topics every so often, so thank you very much.
Thanks, everybody. We'll send you a link to the recording pretty soon.
Thanks. Bye.